Good morning, students. Now, this is the unit 3. Unit 3 is conicoids. The syllabus is the conicoid general equation of the second degree intersect second degree, that's it, and intersection of a line with a conicoid, plane of contact, enveloping cone, and cylinder. Right now, these are the some examples of the surfaces. One is a second degree equation ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy 2ux plus 2vy plus 2wz plus d is equal to 0. Any second degree equation in x, y and z represents a conicoid, or you can say quadric, right? Any second degree equation in x, y, z. Now this is the equation, general equation of a conicoid. Now these are the examples of some surfaces. X square by a square plus y square by b square plus z square by c square is equal to ellipsoid. X square by a square plus y square by b square plus z square by c square is equal to -1. Imaginary ellipsoid, like this. Some examples of some surface examples are given to you. No need to by heart all these examples, right? Just first one ellipsoid, and the second one imaginary ellipsoid, and then one hyperbolic hyperboloid of one sheet, hyperboloid of two sheets. Just remember these four equations only, right? Now see another surface, some more examples, right? X square by a square plus y square by b square is equal to -1, imaginary cylinder. X square by a square minus y square by b square is equal to 0, pair of intersection planes. And the last one, y square is equal to 0, two coincident planes. Y square is equal to -a square, two imaginary planes. Y square is equal to a square, two real parallel planes. Y square is equal to 4ax parabolic cylinder, right? Only first four equations are important for us. Now intersection of a line with a conicoid. Now the points of intersection of a line with the central conicoid is how to find the points of contact or intersecting point of a line with any surface, right? First of all, suppose if a line is given to you which is in symmetrical form, we have to find an arbitrary point on the line. How to find arbitrary point on the line? Simply we have to equate the line equation to r or t, right? X minus alpha is equal to x minus alpha by L is equal to y minus beta by M is equal to Z minus gamma by N is equal to R or T, you can say. Equate each one to T. X minus alpha is equal to T or R, you can say. X minus alpha is equal to R, x minus alpha is equal to LR, x is equal to LR plus alpha. Similarly, y minus beta by M is equal to R, y minus beta is equal to mr, y is equal to beta plus mr. Similarly, z minus gamma by n is equal to r, z minus gamma is equal to nr, z is equal to gamma plus nr. That means if a line equation is given to you, we are equating to a new variable, say t or small r. Okay, now here we are assuming that that variable is small r. Therefore any point on a line is equal to what? Lr plus alpha, mr plus beta, nr plus gamma. This is a general point, any random point on a line. That means it lies anywhere on the line. If this point is the point of intersection, it also lies on the given surface, whatever it may be the surface. It may be a conicoid, it may be a cylinder, it may be a cone, whatever it may be, right? Simply we have to substitute that point in the given surface equation. You will get the values of r, right? You will get a quadratic equation. Now every quadratic equation has at most two roots. You will get two values for r, right? Now those values we have to substitute in the point. You will get 2 points of intersection. What is the procedure to find the points of intersection? We have to find an arbitrary point on a line. How to find an arbitrary point on a line? We have to equate the equation of the given line to t or small r. From there you will get x, y, z values. Those values are called a random point coordinates of the line. Random point means it lies anywhere on the line. Now Next one, tangent plane. Tangent plane at alpha beta gamma of the conicoid is given by a alpha x plus b beta y plus c gamma z is equal to 1. Right? Tangent plane means which touches the given surface at a unique point. Right, at a unique point. That means you should know the equation of a plane passing through a single point formula. What is the equation of a plane passing through a single point for a point, one point formula? A into x minus alpha plus b into y minus beta plus c into z minus gamma is equal to 0. Here we have to remember this plane tangent plane formula. Tangent plane of a surface at the point alpha beta gamma is given by a alpha x plus b beta y plus c gamma z is equal to 1. Condition that the plane lx plus my plus nz is equal to p should touch the central conicoid ax square plus by square plus cz square is equal to 1 is is this one. See, L square by A plus M square by B plus N square by C is equal to P square. Right? And the point of contact be L by AP, comma M by BP, comma N by CP. It's a simple formula. No need to remember this one. Now, the enveloping cone of the conical. Next third page, no? Right. The plane of contact, the point of intersection of the tangent plane at the point to the quadratic cone is called plane of contact. Now that means at a particular point some surface is given to you. On the surface there is a point, say xyz. Now at the point of intersection, that plane is called a plane of contact. That means if a plane passes through a point on a given surface, that plane is said to be a plane of contact simply. Right? This point lies on the quadratic plane, tangent plane. Plane of contact for the point alpha beta gamma is a alpha x plus b beta y plus c gamma z is equal to 1. Right? Now this is the important formula I told you, no? Right. Now a alpha x plus b beta y plus c gamma z is equal to 1. Next one, the polar plane of a point. It's just a definition. No need to by heart this definition. It's not that much of importance. Right? Now, if a secant APQ through a given point A meets the conicoid in 2 points P and Q and the point R to be taken on this line such that the point A and R divide the segment PQ internally and externally in the same ratio, then the locus of the point R in a plane is a plane called the polar plane of A. That means suppose you have to choose a points on a given surface, a point which divides the line segment PQ in the same ratio, then the locus of those points forms a plane and that plane is said to be a polar plane simply. The polar plane of the point alpha beta gamma with respect to the conicoid ax square plus by square plus cz square is equal to 1 is the plane. Again same equation, a alpha x plus b beta y plus c gamma z is equal to here 0. See, right? Now next, enveloping cone. Here this is very important. Enveloping cone, remember this topic is very important in the third unit. Right, the locus of the tangent lines to a quadratic through any point is called an enveloping cone. Please go through the definition carefully. The locus of the tangent line to a quadratic means quadratic cone through any point is called an enveloping cone. Next, an enveloping cone of the conicoid ax square plus by square plus cz square is equal to 1 with its vertex at alpha beta gamma is this one. This formula you have to remember. This is very important formula. right? In entire third unit, you have to by heart this formula. The equation of the enveloping cone with respect to the conicoid ax square plus by square plus cz square is equal to 1 with its vertex at alpha, beta, gamma is ax square plus by square plus cz square minus 1 into a alpha square plus b beta square plus c gamma square minus 1 is equal to a alpha x plus b beta y plus c gamma z minus 1 whole square, right? Or simply s into s1 is equal to t square, where s is equal to ax square plus by square plus cz square minus 1. S1 is a alpha square plus b beta square plus c gamma square minus 1, and t1 is equal to a alpha x plus b beta y plus c gamma z minus 1, right? Now enveloping cylinder, right? There are two important topics are there in this unit. The first one is enveloping cone and this one is enveloping cylinder. The locus of the tangent lines to a quadratic parallel to any given line is called an enveloping cylinder of the quadratic, right? The locus of tangent lines to a quadratic, that means quadratic cone parallel to any given line is called an enveloping cylinder of the quadratic, right? Next one is equation of the enveloping cylinder of the conicoid ax square plus by square plus cz square is equal to 1 with its generator should parallel to the line x by l is equal to y by m is equal to z by n is again ax square plus by square minus cz square minus 1. Here al square plus bm square plus cn square is equal to alx plus bmy plus cnz whole square. Just compare these two equations. Just small difference is there, that's it, right? Enveloping cone and enveloping cylinder with respect to conicoids. Please don't confuse with the with the second unit, right? Now find the points of intersection of the line, right, with the conicoid. Now how to find the points of intersection? Simply what you have to write the given equations. One line equation is given to you, right? Now another surface is given to you. Now what we have to do to find the points of intersection? We have to choose an arbitrary point on the given line. How to choose an arbitrary point or a random point on the given line? Now we have to equate the given line to a variable r or t. Here I am equating the given line to a variable t. Now x plus 5 by minus 3 is equal to t, x plus 5 is equal to minus 3t, x is equal to minus 3t plus minus 5. Now this is minus 3t minus 5, t plus 4, 7t plus 11. This is a random point on the given line, right? If this point is the point of intersection of the surface, then that point lies on the surface, no? That's why we are substituting the x is equal to this one, y is equal to this one, z is equal to this one in this equation, right? Now by substituting that equation we will get a quadratic equation in t. We know that every quadratic equation has at most two roots. Now we are getting two values for t. Those values are minus 1 and minus 2. Now we are substituting those values in this point, right? T is equal to minus 1 point, t is equal to minus 2, we will get another point. Therefore those points are the points of intersection of the line and the given surface, right? What is the concept here? How to find the points of intersection? Means we have to choose an arbitrary point on the given line and we have to substitute that point in the given surface and solve it. You will get a quadratic equation in a t, right? Simply substitute those values in a random point. You will get the points of intersection, right? Now the second one, find the equation to the tangent plane 7x square minus 3y square minus z square plus 21 is equal to 0, which pass through the line, which pass through 7x minus 6y plus 9 is equal to 0, comma z is equal to 3. Now here one surface equation is given to you. This is a line equation. See, it is called a line equation, right? Line equation, this means this is a first degree equation in xyz comma another first degree equation in xyz. This represents a line. Two planes put together represents a line. This is unsymmetrical form. This is the equation of a line in unsymmetrical form. Whereas this one compared with the previous problem, this is the equation of a line in symmetrical form, right? Here x minus x1 by L, y minus y1 by M is equal to z minus z1 by N is the equation of a line in symmetrical form. Whereas this one, see, one plane equation comma another plane equation put together is called a line equation.